or it is based on some business unit name. So all the schemas belong to that group exist at one place. So whenever you try to register a schema, first you define schema metadata. So what are the properties that it has? The name, the type. Type is what is the protocol type. It can be Avro or protobuf or whatever custom type. So description, which describes about this particular schema, and compatibility policy. So this is about the compatibility among different versions of the schema. And you can even have serializer and deserializers very specific to a particular schema instance. So for each schema metadata, you can have multiple schema versions. So each schema version can contain what is the version identifier, it is an int, and what is the actual schema, that is a textual format, and fingerprint of the schema. Fingerprint is a canonicalized model which is hashed to create a fingerprint. It is basically a digest of canonicalized form of the textual schema. Okay, this is a basic component architecture. So you can see here Schema Registry web server. It is basically a web application where it has a nice API to register different schemas, serializers, deserializers, and you can fetch latest version of a particular schema. So we have pluggable storage here where you can store schemas and serializer, deserializers. So by default, you get MySQL and Postgres plugins for this schema storage, and for serializer, deserializer jars, so we have HDFS and local file system based implementation. So to access Schema Registry, you can write your own REST API based client. So the client module that comes with Schema Registry, which internally uses REST based APIs, but it has much better handling in like caching and all that. So anybody who wants to connect to Schema Registry, they can use this Schema Registry client to fetch schemas, register schemas, or like even create serializers and deserializers. Sorry. So the integration that we have is with NiFi. NiFi has around 10-12 processors which use Schema Registry. We have implemented Kafka-based serializer and deserializers, which internally uses this Schema Registry. And Streamline also has Kafka source and sink, which use Schema Registry. So before we need to know about what are writer and reader schemas before we get into how it actually works. So writer schema, so whenever you produce messages, right? For example, whenever you're sending messages to a Kafka topic, so Kafka has a serializer and deserializer API where you can serialize that payload in one binary format and push it into Kafka topic, right? So this schema is used, as you can see here, sender, whenever it is pushing it into some target system. So this schema is used to serialize the given payload to the target system. So the reader schema, which is when you see on the receiver side, whenever you receive the payload, so that payload comes with the schema identifier, what it is written with, which is writer schema identifier. So once it is deserialized, you want to project the payload in a different format. Okay, so that is where you use reader or projection schema. So we will get into details once we look at Kafka use case. Okay, this is about schema evolution, how schema can evolve between producer and consumer. So let us say there is a message store here, right? And multiple producers are like producing messages, but they would have started with a version 1 of the schema, but some of the producers they get added later, and they're using subsequent versions of the schema, but they're pushing it to the same message store, right? So you can see here in producers they have v1, version 1, version 2, and version 4. And on the consumer side, they're receiving the same data, but they're projecting or reading in a different format, different version of the schema. So it can be v2, v5, or v7. So this model enables schema evolution at different speed. Okay. So we are talking about multiple versions that are created for a particular schema. So there should be some compatibility among those schemas. So we have schema compatibility policies. So you can there are 4 kinds of policies that can be configured. These are all the best practices that are already there with other schema registry products and whatever Avro provides, right? So the policies that are supported is backward, forward, and both are full, and none. None means there is no compatibility at all, like it is kind of opaque. So backward compatibility. So whenever you register a new version of the schema, right, so that should be compatible with earlier versions of the schema. Let us say there are already registered 3 versions, v1, v2, v3. Whenever you are adding a new version of the schema, v4, v4 should be compatible with all the earlier versions. What do I mean by backward compatibility? So let us say data written from earlier version of the schema, right? So that should be whenever you read that data, so you should be able to project the written data with the new version of the schema. So here you can see v1 and v2. So if you can see here v2, it has one more element called pages, right? And it is of type int. So what happens is, let us say there is data that is coming with version 1, right? So there is no element called pages. So what this does is it adds the default value, so that once it is projected, it belongs to the schema that is registered, which is v2. So forward compatibility. So you already have few schemas, and they should be compatible with the future versions of the schema, right? So other way to read that as like data written from new version of the schema, right, still be read with the old version of the schema, right? Let us say you have v1, right? So it has ID and color, v2, where you have pages, right, here. So what happens is whenever you read from the data like that is generated with v2, right? So whenever you read the same data as read or projection version as v1, so this pages, it should not be there, right? So what it does is internally it drops this element, and the new data would be compatible with the version read schema version, which is v1. The next compatibility level is about full compatibility or both. So you have you're registering new schemas, and that schema should be compatible both backward and forward. So that means whenever you're reading, you should be able to read from the old version of the schema, and whenever you're writing, you should be able to write new versions of the schema. So here you have 2 new elements, pages and title. right? They have default. So this will take care of adding, if those elements are not there, they will be added on the read part. So if you are using V2, V1 as the read schema, right? So V2 is the write schema, right? So they will be added. These default values are added. For forward, it is the other way. So other than compatibility, we have schema composition. So many of the customers, they are asking about this. In Avro, like you cannot refer some other schema within your own schema. So you can compose schemas containing referring other schemas, like for example in XML you used to have XML include. So you define one utility schema or something like that, and you can use that schema in multiple other schemas. So for example here, this is a very simple example. So let us say you define some type for UUID. Okay, here it is basically a string, but it can be a complex type. But this UUID type, you may want to use it in multiple schemas. So what you can do here is, you can say include schemas, and you give the name of the schema that you want to use here, and after that you can use the type directly here. You can see com Hortonworks data types.uuid. So if you look at here, so you have the namespace data types dot name UUID. So the default serializers and deserializers that come up with the schema client library, they'll take care of going through all the dependent schemas and build the resultant schema which contains all the types. So it is all user doesn't really need to care about going through the dependent schemas and building the schema. So this is a typical sender and receiver or producer and consumer flow whenever you're using schema registry. So we were talking about schema registry client and the serializers, right? So whenever you are trying to produce messages or sending messages, so what you need to do is simply set the serializer with schema registry configuration. What it does is, like, you just need to say give the class name, right, and give some properties like schema registry URL and some cache sizes that you want to maintain on the sender or like consumer side. So what it internally does is, the default serializer that come up with, so they internally use schema registry client, and whenever they need to fetch or register schemas, they internally register it, and they maintain a cache of schemas within that client. So this serializer, what it does is, whenever it is trying to send the payload, along with the payload it sends version identifier, right, so that whoever receives the payload, so they can get the respective schema and then deserialize it. If you look at the other part where here the receiver, so they get this binary payload which includes version payload. Then deserializer, it internally uses schema registry client, and if that version doesn't exist in local cache, it goes and fetches from schema registry. Okay, what kind of serializer and deserializer that we have? So the default implementation that we have in schema registry is for Avro. So, and framework allows to add more types of or like more kinds of protocols like protobuf or JSON. So we have three kinds of serializer and deserializer. One is snapshot based serializer and deserializer. What it does is, it realizes the whole payload whenever it serializes, right? It needs the complete payload to serialize the data that is received. Whenever it deserializes, so it has to have all the binary, then it creates the respective type, respective object. And we have a framework here for pull-based serializer and deserializer, but we don't have any implementation for Avro, but I mean, users can write their own implementation and register these serializer and deserializers within Schema Registry so that others can use. So pull-based deserializer, it gives an API to fetch whatever elements that you really need. Sometimes you have a large document which can be some few hundred MBs, and you may need only 1 MB of the data and send it to the next processor within your streaming flow. So you can only fetch those elements and send to the next component. So same on the deserializer side. So push-based deserializer, so it gives a callback whenever it parses the events, right? You will get callbacks or events for each type of the element and each field within that schema. Okay, so as I was mentioning earlier, so Schema Registry, it comes with a client library. So it is basically a REST-based client, and it provides caching and URL selectors. So caching, it does metadata caching and different versions of the schema that are cached so that you don't need to hit Schema Registry as and when it is required. And it even caches deserializer and serializer libraries with the class loaders. So URL selectors, let us say you have a Schema Registry cluster, right? So you may be having multiple nodes. So Schema Registry client can connect to one of the nodes and register the schemas or fetch the schemas. So we have an API where all those calls may go in a round robin fashion across the Schema Registry nodes. Or sometimes what happens is one of the nodes get failed, so it fails over to the other node. So we have multiple combinations of all these selectors, and you can even plug in your own URL selector. So Schema Registry supports HA. So there are two kinds of HA that are provided. So let us say your storage provider, right? What I mentioned earlier, where you can have your own pluggable storage for storing schemas. So if that is transactional, so then you don't really need any Schema Registry node can be used for writing and reading the schemas. So whenever you have more load, you can add more Schema Registry nodes, and they'll talk to the storage to register schemas. But let us say the storage, it doesn't really provide transactional support, right? Multiple guys writing to the same, like registering different versions of the schema concurrently. Then by default, like it supports HA at Schema Registry using curator's later election recipe. So what it does is it selects one of the Schema Registry nodes as the master node, which is used for writing schemas. So all the other nodes which can be used as reader nodes. So, and automatic failover of master happens based on the later election. Okay, integration of Schema Registry. So we have inbuilt serializer and deserializer for Kafka, which internally uses Schema Registry client library. And NiFi has different processors. which use schema registry for fetching and even for serializing and deserializing the schema. So Streamline also uses it for Kafka source and sink. In case of Kafka, by just giving the topic name, it internally fetches the schema, then it shows up that schema in the UI whenever you're creating a source. So that after that you can create your own flow within the Streamline based on that schema. So on the sink side, so let us say you have Kafka source with some schema and you have multiple processors, then that message is transformed into a different structure, right? So you are pushing that into a different topic. So that will be, if it is the same topic, it will be, under the hood it registers as a new version of the schema, or if it is a different topic, if it is there is no schema registered at all, then it registers the schema that is shown for that particular topic. Generally, we suggest it is like you have, it's like it is considered as a table, so you have one schema, but that schema can be evolved. So I was talking about compatibility policies. So the data may change, but there is a compatibility whenever there is a change in your schema for that particular topic. I mean, if you don't know what kind of data that comes, and it is kind of raw kind of data, then like it is binary, so it is kind of completely opaque. So in Kafka integration, so you have producer and consumer. So what you have to do is in producer properties, you have to just give the class name. Along with that, you have to give few properties that are related to the schema registry URL and caching that I was mentioning earlier. So currently in Kafka, so we actually change the payload structure. So here we prepend the payload with version and the protocol, I mean schema version and the protocol version, and it is pushed to the Kafka store, or like it is pushed to a particular topic, right? So whoever consumes this message, so those consumers should use the schema registry's deserializer. Let us say if they're not using this deserializer, they'll have a different structure altogether, because we are prepending with version and the protocol, schema version and the protocol version. So this is kind of limitation in Kafka now, because there is no metadata or header support for messages in Kafka. So the default Avro serializer and deserializers, we have protocol support where the current protocol is like we prepend with the schema version and the protocol version. Let us say we want to implement some other kind of serialization, right? You create a new protocol version and you prepend with that protocol version, and the deserializer gets to know the protocol version. Based on that protocol version, it can deserialize. So maybe we can enhance without really changing the payload of the message once there is a support for headers or metadata as part of Kafka message. So you can even register your own serializer and deserializers for each schema, which can be used by clients. And we have an API to get the default serializer for a particular type, and they can use, they don't necessarily create these serializers and deserializers. NiFi integration. So NiFi has a controller service which exposes different kinds of operations to serialize and deserialize and fetching different versions of a schema. So this controller service can be used in any of the NiFi custom processors. And there are few inbuilt transform processors that can be used directly, like from Avro to CSV, vice versa, and Avro to JSON, JSON to Avro, and JSON to CSV, and CSV to JSON. So they even have extracting selected fields from the payload in a processor, in a transformation processor. So this is just one screenshot of the schema registry UI. So you can have multiple, you can see here this is the name of the schema and number of the versions, and this is the compatibility setting that is configured for different versions of the schema, and this is the group that I was talking about. So yeah, we'll be adding more features into this. Yeah, this is about work in progress or future enhancements that we have planned to do. One is security, Kerberos support, that is already work in progress. It is being reviewed, and we are going to add default authorizers so that like for a particular schema can be accessed by a group of users. And archiving schemas, what happens is like you register a schema and you have multiple versions. Now you don't want that schema to evolve. You want to slowly archive that schema so that others won't register new versions of the schema. And we'll be giving some workflow kind of thing using notifications. So whenever you register a new version of the schema, whoever wants to consume all the notifications, so they can get notified so that they can take some action based on, like let us say I'm going to archive, so they're going to talk to the like whoever is responsible for that schema and take the what is the next step to consume new set of schemas. And we are going to add converters, like in earlier slide there were from CSV to Avro and all that, right? So that is there in NiFi. So the plan is to have some kind of library within schema registry so that other components can use those converters. Okay, so this, schema registry, it is in Hortonworks GitHub repo. It is open sourced under Apache license, and couple of days back, like we created one Google group so that you can start posting questions and all. And we are planning to have this incubated in Apache so that people, all other products can use this. And we wanted to have contributions from outside. So contributions are welcome in any way, like doc or like tests or like any kind of enhancements. Yeah, that's pretty much I had. Any questions? Yeah. Yeah, tell. Sorry, I'm not able to hear.
Is it possible to integrate the schema registry with Is it possible to integrate a type metasploit?
Yeah, it is possible. Like you just need to have, you just need to use schema registry client.
When you create the external network, you use
Sorry?
When you create or you want to use it, do you just pass the source or the schema into the client URL?
Yeah, right.
And do you point to the last version or you point to a specific version?
That is up to you. Whenever the Schema Registry has a nice API, the client, so whenever you say get latest version, whatever is the latest version it gives you, or you can ask for a specific version. Yeah.
My business detail. What is there an API for HTTP requests as well? So I have any service just make an HTTP request for the kernel to get the schema?
Yeah, you can use, there is a REST-based API that is documented, so you don't need to really use Schema Registry client.
I guess some analysis in this compatibility problem between schemas. And what I found is that, especially in the streaming scenario where you have a Kafka that persists messages, I came to the conclusion that you in general always need both backwards and forwards compatibility with schemas. Yet your tool supports choosing that. Why is that? When do you need that?
No, it's not always the case that you need to have both. Like sometimes you don't want to, you want only to evolve in a backward compatible manner. Like we want to address all the use cases, right?
Will
Yeah.
the schemas be stored as JSON?
Okay.
Will they be stored as JSON?
Yeah, for Avro it is stored as a textual representation, which is JSON. I mean, generally you represent it as JSON for Avro, right? Yeah.
Will this be available in which HTTP version?
Yeah.
Will it then make its way to HTTP to code services?
It is, yeah, it is part of HDF stack, so you can use it. Like it is kind of a microservice, right? It doesn't have much dependencies, so you can always use with HTTP, but it is part of HDF. Yeah, it is similar, but we have we have security and we have many features planned. Like the storage is pluggable, like you don't need to really have Kafka. So we have some use cases where they don't have any Kafka.
My point of view, it looks really similar. So,
Yeah.
why you start this from scratch?
Okay. No, we like our customers. Some of our customers, they're asking. They don't want to be dependent on Kafka. In some cases, they're using NiFi, and they don't want to bring up Kafka cluster for using Schema Registry itself.
Was the serializer and the serializer library stored? Is it downloaded from the Schema Registry, or is it embedded in the product like Kafka or NiFi?
No, it is stored in Schema Registry. There are default serializers and deserializers. That will be part of Schema Registry client library also. But you can always push your serializer and deserializers into Schema Registry.
What was your backend storage sort of thing? At least out of the box. If I want to install the thing that's right there.
Yeah, we support MySQL and Postgres. For storing serializer, deserializers, we have local file system and HDFS. Yeah.
Let's say I have an application with a lot of JSON identifiers. What does it mean to move all of this in Schema Registry? What changes do I have to do in my application?
Okay, so you have some JSON payloads that are coming in.
I already have an application with config files that are equivalent to your JSON payload. So what does it mean to move in Schema Registry? Will I just have to redefine the same
No, you don't need to give serializer and deserializer. If you don't mention it, so you can use the default serializer. For Avro, we implemented default serializers. So we have converters which can convert from JSON to Avro. Then you can use Avro serializer to serialize that payload in Avro format. So on the deserialized side, Avro deserializer, then you convert from Avro to JSON again. Yeah, they don't really transport the schema. They pass some schema identifier along with the payload.
My understanding was that the serializer and deserializer are the things that read the data with the schema that is provided with various technologies.
Right.
Okay, so if I have my own parser of this condition file, I must provide the equivalent class as a serializer, the serializer.
Yeah, see, you can register schema, then you can pass payload by getting, after registration you get an identifier. So you use that identifier along with the payload. So you can manually in the sense you can use the APIs to register your own schemas, and those schemas can be reused on the deserializer side. I don't know whether I answered your question. Yeah.
Maybe of interest to you, in the upcoming Avro 1.8.2 release, there will be built-in support for packaging a record in a format that allows it to be persisted in, for example, Kafka, because then there's a header that includes the schema fingerprint. That will be in the upcoming Avro release as a standard feature.
Okay.
So you don't have to, prevent the schema ID yourself. Avro already has features for that in the next release.
Okay, so it will be part of the Avro record itself in the binary format.
Yeah.
Okay. Yeah, but if we cannot really get the schema from that fingerprint, right? It has to be stored somewhere. Yeah. Yeah. Right. Yeah. Yeah, I mean, in the initial version, we implemented for Avro, and the framework allows to add your own providers. So based on user needs, so we may be adding more. Yeah. Which types? Yeah. It's all, we are using Avro library itself, so that should be supported. Yeah. Sorry? Oh, okay. Streaming Analytics Manager. Yeah, that's what I said, Streamline, which is actually the other name for Streaming Analytics Manager, which uses this schema registry. Okay, thank you.